It runs about 14 miles an hour. You don't need to go. There's bots that'll do 20 miles an hour, but they couldn't hit the side of a barn. I like having more control, and because when you're fighting, nasty spinners, you want to be able to put your wedge right on their spinner. You don't want to, miss and have them catch your front end or rip a tire off, which we've actually lost axles and tires. We fought this. We lost 3 tires and still won the fight. So having backups works pretty good. But we like them to hit us here. This is made to get hit. The rest of the robot, the armor, this is my top armor. It's 60 thousandths. It's not very heavy. If someone comes in and hits that, I've made a mistake. So, and it's all aluminum. The body's all aluminum. So we've got, 1/8" and 3/16 tubing as the frame. But this is a 3/16 AR plate. It's called abrasion-resistant steel. It's what they make dump truck bodies out of. So it takes quite a bit of abuse, even though it looks pretty beat up. It's fought one of the meanest spinners in the sport 3 times in a row, and we were lucky enough to beat him 3 times in a row. So it took a damage, but it did its job. These are basically expendable. That's why I use trailer hitch receiver material, so I can change from this weapon to this weapon, depending on, like, if I'm going against a really a low-profile wedge, I'll put these on, and they float on the floor, and I can get under them and flip them over. If I'm going up against a real nasty spinner, I put this on. So then, exactly, I redirect their energy, because if you try and stop their energy, you're dead. I've seen these spinners. There was a guy that built a bumper for the front of his robot. It was 1 1/4 inch chromoly steel, 6 or 8 inches tall, hardened chromoly, and he went up against the spinner, ran into him, and it actually sheared that material right off. It broke it, 1 inch thick piece of chromoly. And so I figured, you know what, you can't stop their energy. The kinetic energy in a 220-pound full body spinner, the arena can't stop it. It damages it, it stops it, but it damages it. So I basically redirect their energy. I take their energy and let them hit the arena with it instead of hitting me with it. So we tend to try and get them up on top of us and then throw them into the arena wall and let the arena take the damage instead of me. If you do that, you almost can't unless you're attached to the floor. And some guys actually use electromagnets. So when they come up to somebody who's spinning, they'll lock themselves to the floor. And one of them was a hammer bot. So he'd lock himself to the floor and fire his hammer. And if he didn't lock himself on the floor, he'd throw himself 3 or 4 foot in the air. That's how much energy. In fact, one competition wouldn't let him fight because when he energized his magnets, he would bend their floor. And they didn't want him doing that. They could hold this robot, a 220-pound robot, upside down with the magnets. Just hold it. So there's different ways to do it. Basically, all I try and do is to not absorb their energy. It's just to kind of let them skim off me to where I can get under them. Once I get under them, I get to their body, I can do what I want with them and take them to a wall, flip them upside down. Sometimes they just go right over the top of me. But you can. The downfall is very few people build with steel. Aluminum, you're not going to stick to it. Titanium, you're not going to stick to it. So it's more you can use them to stick to the arena floor so you get better traction because the arena floor is like 1/4 inch steel. But some of the ant weights have been doing stuff with magnets, really powerful magnets that either stick them down or I think someone was using an electromagnet to actually float a steel plate off of their robot. So it was kind of like making a cushion, a shock absorber out of the opposite of magnet. I don't know how they did it. There's some weird stuff out there. Right now it's just mild steel. It was a test spinner to see if the RPMs and the design would actually work. It worked fairly well. We're doing one out of a carbon steel now that we're actually going to harden it. But it spins at about 4,500 RPMs and it weighs 28 pounds. So it can take a 120-pound robot and get under them and hit them and flip them over. It doesn't necessarily throw them across the arena, but it'll lift them up and turn them over, or rip things off of it. We've ripped tires off before with it, or at least tore them up, bent axles. The wedges on other robots we've ripped off, so it does all right. But that was our first robot we built that actually had a spinning weapon, and I honestly don't like driving it as much. I like being the kind of the passive aggressive. You know, I like to take on the big spinner.
Hi, I'm Ken Biba, and I'm a member of AERO-PAC, the Association of Experimental Rocketry of the Pacific. And we're a group of experimental amateur rocketry enthusiasts that have been flying in the Black Rock Desert for the past 20 years. And we're associated with the National Rocketry Association called Tripoli. And we fly high-power rockets that go faster than most jet fighters do. Examples of rockets that we build are the three you see back here. We see two that on the end here, Saturn V and a model of a Mercury rocket. These go to about 10,000 feet, and they're scale models of the real rockets. Another example of a rocket we build is one in the middle here, which is a group project to go to 100,000 feet. And that's a project that will also take up student satellite projects like these CANSATs that are telemetry that students can build, and we fly them up to that speed. These rockets go anywhere from about the speed of sound, or about 700, 800 miles an hour. The one in the middle will go up to about 2,000 miles an hour. They're built out of complex materials of carbon fiber and fiberglass and epoxy, mostly composite materials. They fly on solid fuel rocket motors. We have an example of a large rocket motor over here. Much in the same way you see on the shuttle solid rocket boosters or on commercial and military rockets. We fly with appropriate licenses from the FAA to get to the correct altitude, and from the Bureau of Alcohol, Tobacco, and Firearms to fly with the proper licenses to handle the solid rocket fuels.